first step is to mask the empty reactor. We always mask the reactor before adding any plastic so that we can measure how much mass we're actually able to fit in the reactor for each run, with the goal being 1 kilogram. We then load the reactor bed with plastic. For this run, we loaded the reactor with syringes that are primarily made of polypropylene and then recorded their mass. We also added polypropylene pellets to fill the spaces between the syringes and increase the total mass packed. After the reactor is loaded, we mask it again and record the total mass of syringes and polypropylene pellets that fit. Next, we load the Raschig rings into the packed bed, which sits above the reactor bed. These rings provide extra surface area that helps with the condensing of the shorter chain hydrocarbons. After loading the Raschig rings, we place the gasket on top of the packed bed and close it tightly using a torque wrench. We then add a small amount of silica alumina to act as a catalyst during the pyrolysis process. We then use the torque wrench again to secure the packed bed on top of the reactor bed. Once secured, we place the reactor on its stand and put a heating plate under the reactor to provide more bottom heating. This reduces the amount of plastic that doesn't get reacted by just the band heaters along the side of the reactor. Next, we fasten the condenser to the top of the reactor that speeds up and controls the condensing of the pyrolyzed hydrocarbons. We attach thermocouples connected to a data logger that allows us to monitor the temperature throughout the run. We attach the ground wire to one of the legs. We then connect the data logger to a computer to save the data from the run. Also, we place glass wool around the reactor to improve thermal insulation. A beaker goes under the condenser to collect the product. We then start the run by flipping the switch and clicking Start on the computer program. Finally, we collect a sample of the product to analyze later and produce a chart of the distribution of the carbon chain lengths. Here you can see a sample of the product as well as the carbon distribution. And these are samples from other runs.